Artificial intelligence, AI, weapons are rapidly evolving, transforming modern warfare by integrating autonomous decision-making, advanced analytics, and machine learning algorithms. These technologies are enhancing the capabilities of both offensive and defensive military operations. The development of AI-powered weapons is reshaping how conflicts are fought, from smart targeting systems to fully autonomous drones. Here's an overview of how AI weapons are evolving and the implications of these advancements. Autonomous weapon systems. One of the most significant areas of AI evolution in warfare is the development of autonomous weapon systems, AWS. These systems can operate independently, without direct human intervention, relying on AI to make real-time decisions. Examples include autonomous drones, unmanned ground vehicles, and maritime systems. These systems are capable of identifying targets, assessing threats, and executing strikes with minimal human input. Key advancements: target recognition and identification. AI-driven systems can process vast amounts of sensor data and video feeds in real time to detect and classify potential targets. This reduces reliance on human operators and increases precision. Swarming technology. AI enables groups of autonomous drones to work collaboratively, executing complex missions such as overwhelming enemy defenses or conducting surveillance over large areas. Swarms can self-organize, adapt to changing environments, and engage multiple targets simultaneously. Human out-of-the-loop systems. More sophisticated autonomous weapons may operate with little to no human oversight, making decisions about when to engage targets based on pre-programmed rules or real-time analysis. AI-enhanced cyber warfare. AI is playing a growing role in cyber warfare, where it is used to both develop new cyber weapons and defend against cyber threats. AI-enhanced cyber weapons can autonomously search for vulnerabilities, launch attacks, and adapt to countermeasures more efficiently than human hackers. Similarly, defensive AI systems can detect and respond to cyber threats faster and with greater accuracy. Key advancements: automated vulnerability detection. AI systems can continuously scan networks and software to identify weaknesses that could be exploited in cyber attacks. This allows for quicker discovery of zero-day vulnerabilities. AI-powered malware. AI is being used to develop more adaptive and resilient malware that can evade detection by traditional cybersecurity tools. For example, malware can learn from previous attempts to neutralize it and adjust its behavior accordingly. AI defenders. On the defensive side, AI-based systems are improving the ability to detect abnormal behavior in networks, analyze patterns, and prevent intrusions or mitigate the damage from ongoing attacks in real time. AI in surveillance and reconnaissance. AI technologies are revolutionizing surveillance and reconnaissance missions by enabling the rapid analysis of vast amounts of sensor data from satellites, drones, and ground-based systems. AI systems can identify patterns and anomalies that might indicate military movements or the presence of hidden assets. Real-time data processing. AI can process vast quantities of data in real time, analyzing satellite images, video feeds, and sensor inputs to provide actionable intelligence. This enhances situational awareness on the battlefield. Predictive analytics. AI algorithms can predict potential enemy movements or strategies by analyzing historical data and current battlefield conditions. This predictive capability can inform military planning and decision-making. Facial and object recognition. AI systems are increasingly being used for facial and object recognition, allowing military forces to identify persons of interest, vehicles, or weapons on the battlefield or in urban environments with high accuracy. AI in decision-making and command systems. AI is being integrated into military decision-making and command systems to assist human leaders in making better-informed decisions during high-pressure situations. AI-driven war gaming. AI-powered simulation systems can run through millions of war game scenarios to evaluate different strategies and identify the best course of action. These systems can also adapt to changing battlefield conditions and adversarial moves in real time. Decision support systems. AI systems provide commanders with insights by analyzing various factors like troop movements, enemy positions, weather, and logistics. They help optimize resource allocation and reduce decision fatigue in fast-paced combat environments. Adaptive command and control, C2, AI-driven C2 systems allow for more flexible and dynamic responses to battlefield developments, enabling forces to adapt faster to unexpected changes or threats. AI in robotics and drones. The development of AI-powered drones in robotics is one of the most visible examples of AI weapons. Drones and autonomous robots equipped with AI capabilities are being used for surveillance, combat, logistics, and even battlefield triage. Combat drones. AI is enhancing the autonomy of drones, allowing them to perform complex missions without human intervention. For example, AI-controlled drones can carry out surveillance, strike missions, or engage enemy air defenses while minimizing the risk to human pilots. Logistics and support robots. AI-powered ground robots are increasingly being used to transport supplies, assist with battlefield evacuations, or perform reconnaissance missions in dangerous environments, reducing risks to human soldiers. AI-assisted battlefield medics. Robots equipped with AI capabilities are being designed to provide battlefield medical assistance, including autonomous triage, evacuation, and even surgery in some experimental cases. AI in hypersonic weapons. Hypersonic weapons, which travel at speeds exceeding Mach 5, are becoming a key focus in modern warfare. AI plays a crucial role in the guidance systems of these weapons, which require rapid processing of data to navigate at extremely high speeds and avoid interception. Precision targeting. AI algorithms help ensure that hypersonic missiles can adjust their trajectory mid-flight, avoiding defenses and improving targeting accuracy. Adaptive countermeasures. AI helps hypersonic weapons evade anti-missile defenses by predicting interception attempts and adjusting flight paths dynamically. AI in electronic warfare. Electronic warfare, EU, involves the use of electromagnetic spectrum to attack or defend against adversaries. AI is transforming EU by enabling faster and more adaptive jamming, spoofing, and detection techniques. Adaptive jamming. AI systems can autonomously detect enemy communication or radar signals and deploy jamming techniques to disrupt them. AI can adapt to changing frequencies and countermeasures faster than human operators. Cognitive EU. AI-powered electronic warfare systems can learn from enemy tactics and adjust their strategies accordingly, making it more difficult for adversaries to predict and counter EU measures. Ethical and legal challenges in AI weapon development. As AI weapons evolve, ethical and legal questions have come to the forefront. Concerns about the autonomy of lethal weapons and the potential for unintended consequences, such as civilian casualties, have sparked international debate. There are ongoing discussions around creating international norms and regulations to govern the use of AI in warfare. Key issues: lethal autonomous weapon systems, laws. Fully autonomous AI weapons that can make life and death decisions without human oversight raise serious ethical concerns. Critics argue that removing humans from the decision-making loop could lead to increased risks of unlawful killings or violations of international humanitarian law. Accountability. Determining responsibility in the case of AI weapon failures or unintended consequences is another major issue. If an autonomous system causes civilian casualties, it is unclear whether the responsibility lies with the developer, the operator, or the AI itself. AI bias. AI systems can be influenced by biased data, leading to inaccurate or discriminatory targeting decisions. This is particularly concerning in surveillance and facial recognition systems used in military contexts. Conclusion. The future of AI weapons. AI weapons are evolving at a rapid pace, bringing both new capabilities and challenges to modern warfare. From autonomous drones and advanced cyber tools to AI-assisted decision-making systems, the battlefield is being reshaped by intelligent machines capable of faster, more precise, and more adaptive operations than ever before. However, as the development of AI weapons continues, so too must the conversations around their ethical use, regulation, and the potential risks they pose to humanity. The future of AI in warfare will likely involve greater autonomy, increased integration with traditional military assets, and new strategies that leverage AI's ability to process and act on information faster than human counterparts. This evolution will shape the strategies and tactics of militaries worldwide, as they adapt to the growing influence of AI on the battlefield.